Hello, everybody. Welcome to the webinar today. We're going to talk about Rcpp with Dirk, the package author and maintainer. So I'm going to just talk about some quick logistics information before we get started. So the GoToWebinar control panel, if you have not used GoToWebinar before, there's an orange button here and there's an arrow on it, as you can see. And when you click that button a few times, it'll toggle your control panel between a maximized state and a minimized state. And once you get it maximized, you can select audio type. Most people are going to use mic and speakers just because it's simple and it's free. If you're in the United States, you can also use telephone, but keep in mind you may be charged money depending on your long distance phone plan. Be sure to close other applications you may have open that could take bandwidth, things like Skype, LinkedIn, Facebook, Twitter, Gmail, etc. And you can make the webinar screen larger if you just click on the corner of my desktop and just drag it into a certain direction. It'll make the screen larger. If you have headphones, go ahead and plug them in. It'll make it easier for you to hear the presenter's voice. And you don't really need headphones, but they help. And iPod earbuds work great, or a headset will work fine. So if you have questions for the speaker about the package, there's a questions pane, and you can get there by maximizing the window of GoToWebinar. And then you just type your question in here and click the send button. I'll get the question, and then I'll verbally ask the presenter during the seminar, and we can do a Q&A at the end. So a little bit about myself. My name is Ray DiGiacomo Jr., president of the Orange County R user group. I am a healthcare predictive analytics consultant, and you can join Orange County R on LinkedIn groups. So this webinar is brought to you by the Orange County R user group. We're going to record the webinar, so if you have any colleagues that could not make it today, let them know the webinar is being recorded. And you'll get an email today with a URL to the recording. Give us about 7 days to upload the recording, and the URL will point to the proper site within the next 7 days or so. And just wanted to make a quick announcement. So the Orange County R user group is going to be hosting some R webinars pretty soon. So on May 21st, which is tomorrow, we're going to do a webinar on the R Selenium package, which is a package used to test Shiny applications. So if you're a Shiny app developer and you want to learn how to automate the testing of your Shiny app using web browser automation, go ahead and join us tomorrow morning, California time. So that's R Selenium. And then on June 24th, we're going to talk with the package maintainer of rough sets, and that's fuzzy rough set theory. So that was going to be a webinar on June 24th. Look forward to that. You can register at liondatasystems.com/events, liondatasystems.com/events. So without further ado, I'm going to turn things over to Dirk. And Dirk, I'm going to make you the presenter now. And when you get the pop-up, go ahead and show your screen, and then you can go ahead and introduce yourself. I can see your screen. Looks great, Dirk. Go ahead. You have the floor.
Thanks. Thanks so much, Ray. Thanks for setting this up. Thanks to the Orange County R users group for having this. I had taken one of these before, so when Ray sent me an email and asked whether I'd be interested to do that, of course I jumped at the opportunity. So this is the first time I'm doing this over the web. It's a little bizarre, of course, to not have eye contact with the audience, but I trust that everybody has gotten the instructions from Ray. If you have any questions, pass them along through the chat window and ask them. We can definitely do that during the course of the presentation as well. I reckon that this presentation will run for maybe 30 to 40 minutes, so we should have time at the end for questions and or demo. And with that, I think I'm going to get started. So this is about Rcpp. Rcpp is an extension package for R that allows you to bring compiled code pretty painlessly to R. It's the work of several people. It has grown considerably over the years and is in quite wide use. Um, Presenting it to its fullest extent in 40 minutes is next to impossible. I have given several full-day seminars that are 6 hours long, several 3-hour seminars preceding USR and other conferences also, 60-minute tutorials. I'm just going to keep it relatively introductory, relatively hands-on and short on theory. There's always a little bit of extra behind, and if you feel that something's missing, you should by all means come to the mailing list or ask me otherwise. So quick introduction what this is. And in the past, I often started just with more abstract things. Oh, you need to compile something, or how would we have done this in R beforehand? But there's really no need for that. One can jump right in and get going, and one could do much worse than doing this in RStudio, which is a wonderful environment for all things R. And one of the RStudio founders is a core contributor to Rcpp. So if you want to work with RStudio, with Rcpp, RStudio is a good choice. If you just go to File, New File, you already get a choice for a C++ file, which will then, if you click this, insert the following file into your editor. And this is a complete, commented, and self-sufficient file that shows you how easy it can be to get the simplest things going with Rcpp. What it does should be familiar to C programmers and C++ programmers. The first line includes the header file. That is how C and C++ operate. Declarations of symbols, in particular functions, are included in headers, and one has to bring those in to tell the compiler about the existence of certain symbols, notably functions, objects, classes, all that good business. Using namespace, Rcpp is a C++ convention that allows you to shorten your use in namespaces. C++ has namespaces in a way that's syntactically similar to what R does. One uses the double colons, and if one doesn't always want to write Rcpp double colon name of the symbol, one can use using namespace to basically flatten that namespace. That's what we do here, just for ease of use. Then there's a little bit of comment that got inserted, and it says how to drive it in RStudio. Easiest use is just by clicking a button that's visible. We don't see this now on the slide. You would see it in your RStudio session. And if you follow the help link on the editing button, that's, as so many things, context sensitive in RStudio, it'll take you to help on Rcpp. They have some very fine documentation at the RStudio websites. Some of it deals with setting things up and installing dependencies, something I will not cover in the talk here because it leads us astray. In order to use Rcpp on your machine, you need to have the same tools that you need to compile packages from source with R. What does that mean? For a Windows user, this can mean a foreign world. As a Windows user, what you usually do is you install R as a precompiled binary package, maybe alongside with RStudio, and then you install packages. Packages come to you on Windows as zip files that contain the already compiled code. At this point, you've never seen a compiler, and you probably don't have one on your machine. You're just running the precompiled application. It's somewhat similar on the Mac, where the TGZ, I think they're called, extensions also contain the object code. But whenever you're working from code, when you actually want to look at the innards of a package, or you want to modify one, or you want to write one, you have to install the tools, which can be a little bit daunting for Windows users, but it is fairly extensively documented, and none of that is particular to Rcpp. You can just rely on the general R documentation to do this. So I'm not going to get into this and just assume that your computer is equipped to work with Rcpp. So at that point, you can just compile this function. What does the function do? The function takes an integer, an argument that we call x, returns an integer, and just multiplies by 2. The line above the function definition is peculiar and specific to Rcpp. It's formed as a comment. It's after the 2 slash marks, and it's typed as an attribute. That's something that will be coming to C++ as a standard extension. At this point, we're just using it sort of as a meta symbol, and it is a tag for us to know that this function is one that you want to be exported to R. So if you then just basically hit the button, compile this for me, the following two lines, if you do it in a studio button, will get printed in your command console. So it invokes the source CPP function from the Rcpp package, prefixing the package with Rcpp : so it will work whether you have Rcpp already loaded or not, and then sources a file. I'm skipping over one minor step in between now. When we created this file, it was so far an unnamed buffer, so the computer doesn't really know what file name this buffer would have because it doesn't have one. So when you first do this, you will get the normal file browser selection, and it'll ask you to save the file as something. Here I kept it as a subdirectory to my presentation, so the file is now called ×2 in the subdirectory files. And the source CPP function then does the work. It just generates a new function for us that's accessible in R called ×2, which is the same identifier we use in the C++ code. When we call ×2 with a numeric argument, here 21, we get back the argument ×2, 42. The function does exactly what we asked it to do and got built and loaded in no time. So stepping back, what just happened? We defined a simple C++ function, or rather, we got the sample function that the Rcpp, that the RStudio environment provides when one asks for a simple C++ file. That function works on a single integer argument and doubles it. We then ask Rcpp to source the file for us, and that uses a function that Rcpp provides, which in spirit is similar to the source function in R itself. It does all the necessary scaffolding behind the scenes to make the code that we provided a complete self-contained source file that's sufficient. There's a little bit involved. You can see exactly what happens if you turn the option verbose to true. Rcpp then takes this, compiles, links, and loads it, and from that moment on, it is available in our session. That actually is a pretty neat trick, because whenever you, if ever you have worked with compilable extensions to R or other scripting languages, it often meant getting out of your session, doing something in command line, fiddling with the makefile, setting things up, seeing that it compiled, going back to the other session, loading the object file, finding the identifier symbols. All of this is automatic here, and that's a great sort of ease of use advantage, which lowers the barrier to working with Rcpp, and I think is one of the reasons why it's become so popular in the last few years. The CPP function the source CPP function that got invoked there has two simpler cousins. The first one's eval CPP. We're just submitting a simple string expression that is taken as literal C++ code. In the example on the slide, it's 2 × 2. That, of course, would also be a valid C or even R expression. We're not doing anything specific here. But anything that's syntactically valid, you can try. We often use this as a simple immediate test to see that your compiler is set up properly, because if you don't have this compiler right or something else goes wrong, you're not going to see the answer that you expect, 4 in this case, but rather a set of copious and possibly odd-looking error messages. But when everything is set up, it should just work. Source CPP works on a complete file that's being read and transformed into code you can execute. A simpler version is CPP function, where you can have an expression just on one line. What we're having here is the functional equivalent. I just call it under a different identifier, now ×2 with the digit rather than the word 2, so that we have two distinct identifiers. Otherwise, it does the same. Takes an int, returns an int, and does the transformation. And unsurprisingly, when we hit return here, the computer will pause for just a second, or fractions of a second, depending on how powerful your machine is, and we get a new identifier ×2. The neat thing here is that the identifiers we use in the C++ code become the identifiers we use at the R code, so no random identifying names, no mapping. And unsurprisingly, 123 × 2 becomes 246. We will come back briefly to these functions a little later. Vision. Where does this sort of fit into the larger R universe? And we were once out in Palo Alto visiting with John Chambers, and he showed this slide to us, and he had just given a talk at Stanford the preceding months, I believe, where he dug this out. This is from, believe it or not, 1976, right at the beginning of the design of what became S at Bell Labs. You see the dates in the top right corner. It talks about the design with an inner in the circle functionality ABC, a function ABC that will do some scientific computing, which at the time, of course, was in Fortran. Wrapped into an outer wrapper XABC that provides the access to the ABC functionality, and then a little bit of a discussion how arguments could be passed to XABC so that ABC can work and then returns them back. The idea really was to have a seamless interface from a higher level environment where people can work with more powerful compiled code at the lower level and make the transition as seamless as possible. And John's a big supporter of Rcpp and related projects because he thinks that this is really something that finally realized this vision. The thing that's nice about Rcpp is that it allows us to operate on whole R language objects, and I'll give you some examples a little later, or that's the next section actually, objects. What do we mean by that? So here, for example, are two simple functions that just, in a very pedestrian way, take an integer vector and a numeric vector, and in the body of these functions, access functionality of those vectors. For example, inspection, we have a member function, that's C++ parlance for a function that belongs to an object. Size, that tells us how long the vector is, and we can then loop. As it's common in C and C++, looping runs from 0 to 1 minus the length of the object. So for a vector of size 10, we would index n from 0 to 9. And the for loop does that and double every element. Another thing that's sort of worth pointing out here is that the language really is typed. So an integer vector is something else from a numeric vector. We often get transitions from one to the other, just the same way that it works in R. When you multiply an int number with a float number, you get a float or rather numeric back. But here the two are different, and for our purposes, we have to have different function identifiers when the signature on the right hand side is different. That's not the same as pure C++ code, but that has to do with the fact that we're going through a C interface to actually get to the core. But big upshot here is we can work on whole things, vectors, for example, that describe their size, get a vector in and a vector out. Nowhere anywhere are these two helper functions limited by the size of these vectors. They could be of length 3 or 3 million for as long as the amount of RAM on your machine and the patience that you have is sufficient. You can run these operations. Mind you, you don't even need to have patience because something like this is where the compiled code will outshine the R code, and looping over a vector of just about any length in just one pass will be very, very quick. But this is C++. And C++ can work on objects. A simpler version of achieving the exact same result can be had by just receiving the vector, be it int or numeric, and just multiplying it by a number. Because the C++ language can work on whole things similar to how R does it. And here we're representing the vectors we're getting from R as objects from a type that's particular to Rcpp, that are an Rcpp contribution, numeric vector, integer vector, and those can operate on multiplication with scalars, which is convenient. So it's another aspect of why these object and work on object matters. What type of objects do we support? Well, it basically does everything that R does internally. So if you have something in a list, you receive the list in C++. If you have a vector, as we've just seen, it works on vectors. It works on matrices. It works on data frames. And it also works similarly seamlessly with standard C++ idioms that you may have seen if you've programmed C++ before, as for example, standard vector, standard map, standard set, standard list, these things from the STL that came on the scene in the 1990s. We also support various other R types like S4 classes and can get the class attributes and other components. This mechanism is extensible, as we've shown with particularly the packages Rcpp, Amartine, and Rcpp eigen. You could write converters that go from R types to C++ types in code that you want to work with. So one can do this for other things like boost. We have some small examples. We have a little bit for GSL, and it's definitely open for for other work. It's adaptable, and it's really meant as a mechanism. There's a vignette that describes that in more detail. A big deal is working with packages. Working on the command line and working directly with something like CPP function is good. Putting something like source CPP in script is good too, but the unit of operation for the R universe really is packages. Packages is what's on CRAN. Packages is how we organize code, how we disseminate code. So R makes it very easy to work with packages. So we do the same for RCPP. I have another screenshot here from Studio. So for example, if you go into, and I think that's both under the project tab as well as under session or build, there's an option for new package, and you go in, create a new package. In the middle of the screen now you see as type package with RCPP. That's a second value in a toggle that defaults to just create me a package, but it will also immediately create your package with RCPP. There's a very convenient way with the GUI. You can give the name there where it should be placed, but at the end of the day, it just invokes a helper function that's actually already in the RCPP package, and we called it rcpp.package.skeleton, and it's an extension to the standard function package skeleton that base R provides to create packages. We also have variants that create suitable packages for RCP MID and RCP eigen, but just doing the initial steps. Here, for example, is a small subset of, well, there are 2 of the 4 functions that you get when you invoke RCP MID package skeleton. I quite like this example because it just shows you how easy it is to work with these mass extensions. In goes a vector, and you can multiply a vector with itself 2 different ways. You can either create an inner product, which turns a vector of dimension n by 1 into a 1 by 1, a scalar. That's the second example. Or you can create an outer product when you multiply the vector with its transpose. And for an n by 1 multiplied by 1 by n, it becomes an n by n matrix. In both cases, of course, I silently assume that the vector is a column vector. But, well, obviously, the same thing applies to row vectors too, once you transpose them. So working with these very powerful linear algebra extensions provided by Amadio is just as easy. Users, we've been pretty fortunate in that RCP really got picked up by a lot of prominent package authors and packages. So here's just a really short list. Amelia is a package for multiple imputation, both in the time series and cross-section panel sense, by Gary King and a bunch of his students out of Harvard. The LME package, of course, by RCore contributors Doug Bates and Martin Mechler and others, uses RCP eigen to do some things. Rob Hintman in Australia has a wonderful time series forecasting package that does a lot of magic, including automated forecasting. It also relies on RCP Amadio. Andrew Gelman at Columbia has a fairly large and substantial and well-funded project to do new things in Bayesian computing that in a way extends things like bugs and JAX with the Stan project, and in there it's RStan that uses RCPP to get the Stan language things into Quaker compiled C++ code. Alexios Galanos is a developer in London who has fantastic financial econometrics packages, most notably Rugard, another RCP Amadio user. Hadley Wicken became a very outspoken advocate and fan and uses RCPP now in a number of packages. Some just got extended by a function here or two and deploy as a more ambitious rewrite. RStudio itself uses RCPP because the HTTP UV package, which is used as a more general replacement of WebSockets and is integral to Shiny, relies on RCPP. And MTS finally is a package from a famous business school professor here in town in Chicago that works on multiple time series. The count keeps increasing, but as of yesterday, I think we're at 214 CRAN packages and another 27 bioconductor packages. All of those are, of course, out there, and you can just download them, pry them open, look at the code, and see how they're doing. And that's a good way to go about things as well. Some of them are large, some of them are small, but it's a good way just to learn things. And with that, I think I'm jumping sort of into the larger second half of the presentation, and I'll be just going over a collection of examples. If any questions have popped up by now, now would be a good time to take them to Ray. Is there anything?
Not yet. Yeah, you can just keep going.
Perfect. I will do so. So the first example extends a little bit what we've done with the vector examples earlier. So, oh, and I should say, all these examples are coming from a website that Judeon and I put together, which is called gallery.rcpp.org. It's about 80 fully described and self-contained examples that tell a short story and address a particular task, in which you can, in most cases, just download and use. And they illustrate different aspects of Rcpp, and it's an open website. So if you worked out something that you think is clever and noteworthy, by all means, get in touch and send us a contribution. I think we have by now 10 or so different authors on the website. It's just a GitHub pull request or an email with the patch away. So this simple example does cumulative sums. It redoes what we have in R as cum sum. It's a good example to how I go about things. So here, in the first version, we just say in comes a vector x, and we're initializing an accumulator variable to 0, because in the beginning the sum is 0. We then create a new results vector that we call res for result, specifying the size of the x vectors, so they're both of the same dimension, and then we just loop over the two. At each element, the accumulator gets incremented, and its current value after that operation gets stored into the results vector. That's exactly what we want, because the cumulative sum of at the first element is the first element, and at the second element will be the first and second, and so on. And then we return the results vector. It's that simple. It's really just 5 lines of code. We do, however, have the ability to do things differently too, because this is C++, and we can use C++ idioms. Here we're using standard partial sum, one of many algorithms provided in the STL. The way that these things work is that they operate on so-called C++ iterators. So here we get these iterators begin and end from the x vector, meaning that we're asking the function to operate from the beginning to the element just before the end. That's, in other words, the same idiom as this 0 to n minus 1. We want the last element. N points to what would be the location of the element after the last. So by it knows sort of what to do here, and sticks the results into into the res vector that we created. And this would, in a single operation, do the same as what we've done explicitly on the previous slide. So different ways to attack the same problem. There's another variant that uses something that we call Rcpp sugar, and which I talk about a little bit more in longer forms of this presentation. Sugar brings a lot of vectorized operations to Rcpp, and it is an idea like quite a few others in the package of Roman, who has implemented quite a bit for that. It's not everything that R does, but we have probably several dozen, close to 200 functions, and CumSum is just one. The nice thing here is that we get the compactness and conciseness of the R language at the performance and power of C++. So in goes a vector, out goes the CumSum of a vector, and it's to you as a user and programmer just a single function call. And then of course we can do simple things like building these functions, running through two results and comparing them via all.equal. And the results of course are all the same. Another thing which users sometimes find convenient and tempting, though which on occasion also gets misunderstood, is the ability to invoke an R function. That works because Rcpp functions are never standalone like C++ function. It's not code that's used in isolation. It's code that's used in addition to R, in an extension to R. So R is always behind. So functions in the R language are just another type of object. So we have the ability to pass functions around, just how we pass around numbers or vectors. So in this case, we're writing a function that receives a vector and a function, and then we create a new vector as an evaluation of that function on the vector. It's just how your math teacher would write it. So we're applying f of x. And this is not generic. Any function that that takes a numeric vector and returns a numeric vector could be used in this case. And the example that I'm showing there, that's basically how NitHub processes these files. So we can have the C++ code in the file, and if we have comments that start with 3 stars followed by an R, the code is immediately executed. That makes writing and including text and example documentation pretty convenient. So if you saw CPP, the file is seen, it will actually invoke the R function 5 num on a vector x. Actually, it's not quite self-contained because we haven't defined a vector x at this point, but imagine 1 to 10 or I draw from a random number generator. So functions can be passed back and forth. This is very useful whenever you need to test your new C++ code against existing R functionality when you want to benchmark it. You should not assume that this makes the R functions any faster. At the end of the day, this is of course still invoking R functions, so there's performance penalties there. It will not run faster than R does otherwise, and there's a little bit of overhead involved also with calling the function, getting data back and forth. But for initialization, for comparison, for validation, it's a very powerful tool to have. If you've heard about C++, you may well have heard about Boost. Boost is a very massive, very impressive, very thorough project that exists now for over 2 decades. It was just about the first that used the notion of peer review to create high-quality code archives. And its scope is fairly unlimited. Just about anything doable in C++ is being done. Below the top-level banner of Boost is a large collection of library without really a common theme other than that they're all being done in C++ and are really as good as they can be done because it's a multi-year acceptance process for new proposals. I'm showing here an example that came sort of out of my problem domain. In finance and banking, you sometimes need to know when the 3rd Wednesday of a month is, because that's when a particular contract at the Chicago Mercantile Exchange here in town expires. It's an example that I got from a friend in New York initially, and then just used and liked. So here you would just invoke, it's in red in the middle of the screen, a boost function, nth day of the week in the month. And here we're instantiating it with an enumerated constant, nth day of the week in the month 3rd, would select the 3rd week, Wednesday. Note that none of this is in quotes, right? These are now identifier constants in the boost context, and the month that we feed in, as well as the date that we're getting when we're also instantiated with a given year. And we're just converting that back and returning it to R. Some things that are noteworthy are, for example, in the first line, we're now showing Rcpp depends BH. That's another mechanism in Rcpp, and it's Rcpp attributes extension on how we're saying that we're depending on another package we can use. What happens there is that we're pointing to a set of header files, and C++ has a notion of providing code in templated headers. One can organize code this way that provides complete functionality without additional linking. That's quite powerful. And in Boost's case, a very large part of the library is implemented that way. There are only a few sub-libraries that interface more with the system that then need linking. Those we don't have accessible, but most of the others we have via BH, and that basically makes Rcpp aware of us wanting to know where the boost headers are, because we put together a package boost headers and BH that contains them. R will then find them. This particular functionality comes out of a calendaring function, Gregorian calendar, which is why it's called Gregorian types, another namespace handle, and then all this happens. At the very bottom in the last line, you see a little how we're translating from a boost type. The line before stores the results in a date : y&d type variable named y&d, with an accessing of y&d the components year, month, and day. It's sort of very similar to how POSIX-LT decomposes a time object in R into the different components, and we use these year, months, and day components of the date to instantiate an Rcpp date variable, which we're then sticking into wrap. Actually, that I could remove. That would be done automatically in this case too, and it returns. Oh, it is actually redundant because we want to return an Rcpp date. So that's just a little bit of extra code fluff I should clean up for the next iteration. Here's a second boost example that I once put in a gallery post as well. That was before Rcpp 11 came out, that we can now use as well. Boost has a notion of a simpler loop for each, which just loops over a set and accesses each element. So here, for example, we're defining a function square that squares each element of a vector. And you see that we're no longer doing the for I equals 0, I less than size, I plus plus. We're just saying, give me all the elements that are in the vector x, and let's access them by name elem. And then we're saying elem be elem times elem, so we're squaring them by receiving references rather than copies to the objects. We can actually alter their value and then return them back. That was a pretty popular, albeit small, feature of Boost, and C++ 11 has now something very similar in an augmented for loop, sort of for with a new use case. Kevin Hirschy, another core contributor to Rcpp, recently worked on the indexing. So this is something that came with the most recent release a month or two ago. And when you have vectors, you can just index them, for example, by Boolean expressions. Return x of square x greater than 0 square works the exact same way it would work in R. Likewise, you can pick out certain elements of a large vector by indexing with a subset vector. So here we're just saying, for whatever large vector, give me elements 0, 1, 2. We could have said, 3, 57, and 8 as well, provided the vector was large enough within the bounds. So indexing by Boolean, indexing by int, as well as for a list type, indexing by name. Here's another quick example for Armadillo, a linear algebra package I use a lot whenever I need to do number crunching. Again, we're having a dependence on Rcpp Armadillo. That's all that SourceCpp needs to know. We have an export for saying to send the function out, and then we just send in a matrix M of type Armadillo matrix, and we're returning the symmetric eigenvalues. This is accessed via a member function eig_sim. There's also one without the sim, but in this case, this is what we want, because under the normal definition, we want eigenvalues of a symmetric matrix. Quick example that runs it, and when we access this with get eigenvalues of z, that way we get the exact same results vector as when we call it the R function eigen, subject to the ordering. But for eigen problems, the ordering of the eigenvalues and vectors isn't pre-specified, so it's really the equivalent result. Here's a quick example of a page that I put up together with Hadley, who was quite happy when he rewrote some internals of the plier package from plain C to Rcpp. I'm just quoting what he wrote up in the opening paragraph there. What sets sort of up the problem. He needed to loop over elements of a vector and find sets of subindices, not knowing the exact dimensions of things, and it was a relatively hairy C function. And he said it got smaller, smarter, less error prone. He found a bug in the process, and the actual implemented version then is as short as this. So in comes an integer vector and a counter for the number of indices that one desires, and then it basically just loops over these operating on what we have here, standard vectors of standard vectors, so it allows to grow vectors within vectors and uses C++ member semantics to do the memory management properly, because we don't know ex ante how long the results vectors are. This is just something that gets processed here on the fly and is on the internals of Plyer. So Rcpp also helps to just make existing C code a little more manageable, because you can write C++ that's pretty close in spirit to C and just uses certain functions of the language sparingly wherever it makes sense, as in this case, for example, the standard vector class. Seamless interchange of objects. So we can unpack our objects at the C++ level. We can also use C++ functions as factories to create our objects. So something that I work with a lot are time series. And for that, I use the XDS packages of my Chicago friend Jeff Ryan a hell of a lot. And at some point I was wondering, well, how would it be to create such an object at the C++ level? It's actually pretty straightforward. If you've ever worked on R code that creates basic S3 objects, it's really just creating containers, most often lists, if there's things of different lengths in there, and setting a class attribute by using the attr function. Well, that's the internal representation, so it was straightforward enough for us to do the same from the C++ angle. Essentially, we're just setting the various attributes that an XDS object needs to have so that the XDS operations work on it. And I've shown a few here. If you know that XDS objects are, they're essentially a vector or matrix, always numeric, coupled with an index vector. So here I'm just pretending that the vector IND, an integer vector, just a boring sequence, is the payload. So it's not a very interesting example. And that we then have a numeric vector of dates or date types. One commonly uses this with POSIX or date. And those are underneath really doubles. And I just copy the sequence that we have over and multiply it with the number of seconds per day. And I'm getting dates. I set the two attributes that a date type for XDS must have, so a default time zone, and here we're just making it UTC, Greenwich, as well as the class of this object, which we created as a date object. A date object really is a numeric vector with an attribute T class, set to date. And then we have to do the same thing, or some more things with the rest of the objects, but essentially we have to say what the dimensions are, and here we have the length of the sequence from the end value to the start value, I call those EV and SV in the signature of the function, plus 1, and a column of 1, because the dimension really is just the length. We set dv as the index element, that's our date vector that indexes the XDS. We say that the class of this object is XDS inheriting from zoo, so it's a two-level class structure as not uncommon in R, and set this as the class attribute, set the date attribute again for the indexing. There's a little bit of redundancy in the internals. I think that has to do with some versioning in XDS, so I omitted it here because it didn't fit on the slide, but it's essentially the same business. So just a minor amount of hand-holding, and we get something back that is indistinguishable from an XDS object created in R itself, as I show on the full gallery write-up that's indexed at the top. Finally, just to close, the maybe most complicated example, but one that is immensely powerful. If some of you in the audience work on things like optimization, where, for example, you do either numerical optimization with an objective function or just maximum likelihood estimation with a function that you optimize over, often the bottleneck is that we have fast optimizers, or we can borrow code that does fast optimizers, but the function to optimize over is still a bottleneck and is written in R. We can pass C++ function around with the same ease that we can pass R functions around, or just about, and that way have a handle to give the user the ability to provide plug-in objective functions to be optimized over. We can write them the same way we do with Rcpp, using CPP function to set them up on the fly. This example is self-contained, albeit a little simple. So the first function that's shown there is fun_CPP, and it just takes a value and returns it tenfold. In comes a vector, out comes the vector 10 times. We then need a type-def definition to make some of the mechanics that follows flow. That always looks a little bit intimidating, but sort of don't really worry too much about it. It just shadows the signature from the preceding line. On the left-hand side is an armor colon vec, so we're saying it returns an armor vector, and on the right-hand side, the payload is a constant armor vector with the reference. So in comes a vector that we promise not to alter. That's passed efficiently. We need then, other than the actual function that we have, we need a function that wraps the C code in an X pointer object. X pointer is our Rcpp variant of the standard R-type external pointer, and that's what we can use to pass these things around. In the longer example on the gallery story, I show something where you may have several of those and just use a string identifier to switch between them. Here we're just wrapping one in unconditionally to show how the mechanics work. And then finally we have the, the quote-unquote user function that you would have, call a function with the compiled function that we pass down. So in goes a vector and an S expression of such a wrapped function. In its first line in the body, we're instantiating the external pointer function from that S expression that is that uses an X pointer object with the function pointer defined earlier in the type def. Make that then an actual instance of that type def. So func pointer fun is now that signature that we define, and then we can just say, Armadillo, create me a vector y as an invocation of x on the function. And Armadillo at this point doesn't really know that this was once, an abstracted function pointer that we shielded properly to marshal it down all the way to the compiled code, and we return the result. A use case would be, for example, just we use the preceding helper function, put a function in the external pointer to get such a properly set up object, and then we can just pass it down into the caller that we just show, and if we invoke it with 1 to 4, back comes the tenfold result, 10 to 40 in increments of 10. Really simplified example, but keep this in mind. This may come in handy once you're more familiar with Rcpp, and some people found it tremendously useful for some numerically demanding use cases. That's what I had in terms of examples, and just to wrap up, if this whetted your appetite, there's a lot of documentation in the package itself. We have a number of PDF vignettes that you can view immediately. Several of these vignettes for Rcpp and the associated packages Eigen and Armadillo have now been published. We have a pretty decent high signal, low noise mailing list Rcpp eval that I encourage you to subscribe to and maybe just learn and eventually ask questions. It's maybe 3 or 4 posts a day. Stack Overflow is helpful too. We're getting close to 500 posts in the Rcpp tag. Some are basic, some are more advanced. It's a good resource to also just search in the Rcpp tag. And especially in the beginning, I tended to write a number of blog posts in introducing features. Those still come up in Google searches too. But another, one central place where to find good write-ups is the gallery. We have the wonderfully concise URL gallery.rcpp.org with HASA. By now about 80 posts. It's fully searchable via Google as well with an embedded link. So if you have a particular topic, how to do this or that, you can just search and hopefully you will find some stories there. And it's open for contributions. So if you have something interesting that you've done with Rcpp, by all means get in touch, and we'd be happy to show it to the world at large via the gallery. And last but not least, I wrote up a book that came out about a year ago, and which you can get from Springer or Amazon or usual booksellers. So I've taken maybe 5 or 10 minutes more than I thought this would take, but we still have time for questions now, or else I'd be happy to go through a quick example. So with that, let me hand it back to Ray.
Thanks, Dirk. That was a great presentation. So I see some questions coming in here. Let's just start taking them. We got about 10 minutes. We could probably go a little bit over too.
Okay.
All right, so here's one from Ricardo. And Ricardo asks, is it possible to pass data frames by reference and modify them in place? For example, removing an entire column?
Excellent question. Sort of yes and yes and yes. I'm hesitating a little. The last one is a no. So the one thing that we get to that bites us a little with the data frames is that what we're used to in R is that we can operate on data frames row by row. And we can't do that as easily in C++ because data frames, which one sometimes notices in R as well. I think if you unclass on them, you get a list back. Internally, they're really just lists. And what you get there is, oh, here's a search field. I can also, I thought we had a tag for data frame. We don't have a tag for data frame, so let's just search for data frame. Because I think we have articles about that too. So there's for example, one on modifying. That may be a point that flows to the question in mind. So via const via reference, definitely, modifying, definitely, taking one of those objects and setting 1 to 0 efficiently, one would need to measure that. I fear that in the worst case, if you have 10 elements and you want one with 10 minus 1, 9, that you may have to copy the 9 other ones over. On the other hand, it's a way. So in R, what one would do is one always sets an element equal to null. So one can probably get to an approximation of that, sort of to be seen. Likely, but I'm not entirely sure. I hope this helps. Otherwise, I'd be happy to discuss that further with an example on the mailing list. Very good question.
Sure. Okay. Here's one from Raj, and Raj asks, are there any Rcpp examples that leverage MLPack?
That's a fantastic question because I'm such a big fanboy of Armadillo, and MLPack is a machine learning project out of Georgia Tech, which is sort of quote unquote the other big user of Armadillo. Both sides are fully aware of each other. We contemplated creating this as a Google Summer of Code project, but didn't quite get there. MLPack, of course, doesn't just care about R. MLPack is agnostic, and so they had first attempted to get to scripting languages via Swig, and that works, but it's not quite as powerful as this. So we're sort of not there yet, but there are a number of people who want to work on that, and I think 1 or 2 even came forward and want to dig around a little. I'd say come back with that to the mailing list. I'm not aware of existing code examples or an existing corpus of code, but people want to combine these two, and it should be possible because we get to Armadillo easily, and MLPack sits on top of Armadillo, so we should get there.
Okay. Here's one from Judeon, and Judeon asks, for the R users who do not know C++, what are some good resources for them to get started to learn, coding C++ in an R environment?
Yeah, that's also a fantastic question. I mean, that is, of course, that is a bit of a problem because I show a lot of sites, slides or blog posts with short examples that are tempting. The devil does it in the detail. An early reviewer to the Rcpp book also suggested that needs to be addressed, and I wrote an appendix of 5 or 6 pages just trying to introduce C++ to an R programmer. But at the end of the day, I think you just have to buckle down, and if you really want to do it and learn C++, one of the best resources that I know is a massive page on Stack Overflow that got upvoted a lot of times, which quite literally has that in the title. So if you just search on Stack Overflow, resources for learning C++ or the ultimate C++ book list, and as I recall, it's cut into thirds, sort of beginner, intermediate, advanced, and has really good pointers. I personally found the Maya books really helpful, but it depends a little, because invariably, once one starts working with Rcpp, there may be the temptation to do something a bit more ambitious, and that will then require some understanding of Rcpp. So I would start with those web resources and FAQs, and basically try to get to an understanding of C++ as a language, what it does, and then use that with Rcpp rather than drive it too narrowly by Rcpp. Because some of the examples we have maybe doing something idiosyncratic rather than generic. And C++ is a wonderful language and worth learning in it by itself.
Okay, so here's one from Joe. And Joe asks, how can I link libraries and give compiler options?
Best example really is, oh no, sorry, I forgot that. That's, I think my laptop went to sleep. Oh, that's right. See, I'm connected. That was clever. So good thing I didn't promise that earlier. I do that a lot in my own packages. And when I sort of pointed to the 214 packages as of today on CRAN, I would definitely start there. So there's two answers to that. So the one is, the narrow one is, how do I tell the compiler? There's a mechanism called make-vars. So and that's described in writing R extensions. It's the same when if you did it in an R package with just C code or C++ code without Rcpp. You basically have to tell the compiler where to find these and that they are there. So it's the first instance is documentation in writing R extensions. So that points to the make-vars file. In the make-vars file, in the simplest case, you can just use your capital L and lowercase l flags to point to the directory where the files are and the name of the library you want to link to. That gets a little hairier once you want to ship something to CRAN, because you may have to combine that with configure logic to find a certain binary. So it depends on whether it's a library that's already on the system or not. But I have by now sort of a number of packages on CRAN with my name on it, and a very large subset does just that. I mean, and that's how it all started. For example, with the Arquant package, out of which Rcpp grew. It's a very common task. Many packages do it, and there are a number of tricks that can be found by studying the other package resources or by poking into our documentation, because now the screen shows it again. Sort of the Rcpp package talks a little bit about how to use Rcpp in your own packages, and it mentions this problem too. The specifics depend a little on what library you want to wrap, whether it's already on CRAN or not, whether you want to embed the library in your own source code as some packages, like for example RSQLite do. So definitely doable. I'd argue definitely easier than it would be without Rcpp, but because of the nature of the piece, not entirely trivial, because how these things happen behind the scenes do depend on the operating system. R does a fantastic job shielding the operating system from us, but when we want to extend it this way, then we sometimes have to buckle down and be aware of these operating system aspects. But R helps with its package compiling and building infrastructure, and there are tricks one can borrow.
Okay. So here's another one from Raj, and Raj asks, are there any more presentations available on Rcpp, or are there any scheduled presentations coming up in the future other than Use R conference, which is the obvious one? Are there any other presentations?
That's a good question. This is sort of the first time where, thanks to the invitation from the Orange County our user group and Ray, I've sort of taken this to broadcast to the world. I sometimes thought about doing that just with Google Hangouts. Maybe we should just do that on a time that's convenient for other people. Other than that, I sometimes keep updates on my blog, so I recently had one on there because this has been insane. This is my fourth presentation in the space of a week. Because last Wednesday we had a Chicago R users group presentation or meeting, taking advantage of the fact that R Finance came, and R Finance committee members and Josh Ulrich and I presented along with two others, and then I gave a workshop before R Finance or tied to R Finance and a short lightning talk at now this. So I'm a little done. I have another one coming up here in Chicago, but that's for UC students. Then there's Use R, where I'll talk a little, and I think after that my calendar is a little thinner, so nothing scheduled yet. So but I've come to other campuses and given workshops. So I mean, if there's a bit of a budget that can cover travel costs, flight, hotel, or whatever, one can set this up. Other than that, the calendar is not that full. or the publicized events are not yet out. I mean, there's some things in the work, but they're all specific to two universities.
Mm-hmm. All right, let's do a couple more. We're at the top of the hour, but I think we can go over a couple minutes.
I'm fine with that. I'm not being thrown out of the room. So for as long as you have questions, let's knock them out of the park.
Sure. All right. So here's another one from Judeon, and Judeon asks, what are the situations where RCPP is most frequently used? For example, is it used in handling big data? I mean, what are some of the frequent use cases that you're seeing?
Good. I haven't really clustered and grouped it. There were a number of people coming out of various Markov chain Monte Carlo approaches that really liked it, just because when you work by simulation, the speed of your loop matters. So a lot of people picked that up. So I had some friends there at WashU in St. Louis and at UCLA and here in Chicago, and people are happy with that. Bioconductor, because they work a little in a coordinated way across releases, was a little slower, but with the very most recent release, I think number of packages went from 17 to 27. I don't know what all of those do, and they're not all in the same problem domain, but they do some of that. Big data definitely works. I mean, because this gives you a handle to do things with R, but outside of R. So, some people use Rcpp to then invoke, say, big memory objects. There's an Rcpp gallery article on that one as well. Then all of a sudden, your objects are no longer handled by R, and they're just on the box. By the same token, you can get out of R via Rcpp and into object code that then works on a cluster. You can invoke things like MPI. I mean, many things happen are possible this way, but as you said, big data, I can right now not think of another sort of poster child application for big data with Rcpp, but it comes up. I mean, because the key here really is it allows us to go outside of R into object code that uses C++ facilities. And C++ facilities are deeply entrenched in scientific computing and in all forms of ambitious computing over more machines, more memory, and you can use this to hook into things. So a good example, for example, is programming with the big data at University of Tennessee. They had Rcpp in the beginning, but then they found that they needed to slim their code down a little and sort of argued back and forth with them that it's really not much more than other object code invocation. But so they launched R on 150,000 cores, but sadly, in their wisdom, then decided to carry forward without Rcpp. But it helped them a little in the beginning. So in that sense, if the code infrastructure can link to C or C++, then this can definitely help you.
Great. All right. Well, let's do one more. So, does RCPP work with C++11?
Absolutely. There's it works with whatever your compiler does, and I wrote a couple of examples in the gallery on C++11 early last year. It worked with C++11. We used it before too. The problem always was that up until 2 months ago, you couldn't use C++11 on CRAN, because this is often used to produce packages that go to CRAN that limited the usefulness a little. But there's write-ups, there's documentation. That one's now 15, 16 months old. Where's my SOU session? Oh, sorry, I'm at the browser, silly me. So all you do basically is you use something called a plugin, which then uses it. So we can so this will be really simple, but we're just going to say and for some reason, I'm so stuck with these times 2 examples. Sometimes in my life I do more interesting things, but just bear with me. So here we're using the C++ idiom auto, which auto uses the type of the variable, and it will know that in comes an int, and I multiply with an int, so what comes out will be an int. And in order to use that, we just use a plugin. That's something that you would have in the source code. And I can never remember whether we called it C plus CPP 11. I think we called it C plus 11. Guess not. Oh yeah, I didn't have a return statement in there. That will do it. And then if you want to see what's happening, you can just say we're both equal true. So the big key is, I think you can see this here. The machine that we're running this on is a reasonable recent Ubuntu version, so we have a reasonably recent version of G++ in there. So it takes C++ 11 rather than just preceding versions. The same thing would work with some of these flags and names sort of or extensions slightly differently. I mean, this just shows that it's a Linux box. I mean, Windows boxes would be different, but the main key is absolutely C++ 11 is just a plugin, just how OpenMP are a plugin or other things that make sense as a plugin. And now now the function works the way we. Oops, sure, its screen's flickering all of a sudden. There we go, and it came back as, well, mind you, that's not so magic, we actually hard-coded that in there, but we used C++ syntax that plain C wouldn't use. If I did this without the plugin, I will get really obnoxious error messages for which C++ can be famous, because now it's not standard C++ behavior. You know, this actually, under the competition from Clang, G++ got a little nicer too, and it tells us that, I mean, that's very clever. It even knows that it's C++ 11, and right now we can't really use it. Hope that answers it. So definitely open to all different programming paradigms. The idea is you should be able to use C++ 11 when you can. We fully support and embrace it now because CRAN allows it too. The only cost really to you in using is that it will depend on R versions 3.10 or later, and if that's not a concern, you can definitely do that. All programming paradigms within C++ are fully supported because that's what Rcpp is all about, giving you the power to do C++ in any variant from R.
Great, great. All right. Well, there's one question left. We might as well take it. So this is from Vasant, and Vasant asks, is there a page or a resource to help people set up Rcpp on Windows, especially setting up the compiler?
Yes. So, and of course, we address that a little. So there are some notions in here. It's just every now and then these things change, but it's a combination. And one that is pretty good is the one that I had mentioned actually at the beginning of the talk, and which we will get to. So now I can basically just show you live what the first slide did. If you go here and then ask for help, it will take you to RStudio, and then no, that's just the usage case, but it's within the in the very well organized RStudio help as well. So a good one here, for example, is actually no, not we want packages. Yes, package development. Package development prerequisites. This page we actually link to from the Rcpp FAQ as well, and this is pretty decent. So you need this download. Some things are in the manual. If you want to do LaTeX, you need LaTeX from there. So this is as good a starting point as any others. But besides that, writing R extensions covers this as well. It's doable. You just have to follow the instructions. There's some easy pitfalls. You can get into mismatches between the version of the tools and the R version that you're running. So RStudio does some checks on that too. But if you're starting on an empty machine, You can be done in 15 minutes, but be careful. Don't rush. People sometimes then get very frustrated when the 15 minutes turn into a day because they overlooked a small detail. But by and large, it's pretty good. There used to be pitfalls that you could install the tools and then it would still behave badly if you had R installed in a path with spaces. We recommend against that. Ed does the R on Windows FAQ. Oddly enough, that's still the default location when you install R, so sometimes it meant placing it in a different directory. We try our best to sanitize all the paths that get invoked to go to the form that doesn't have a space in there, but the shorter old 8.3 .dos form. It mostly works, and there's lots of posts for help on the internet, so I don't want to waste everybody's time by just repeating that. We help a little in the Rcpp FAQ. R has it in its manuals. RStudio helps a little, and you should be able to get going with that.
Well, great. So I think that's it. We went a little over, but we had a lot of people stay till the very end, even past the end of the webinar at the top of the hour. So there's a lot of interest. Seems like you have some pretty good fans here.
Very good.
So thank you, Dirk. It was a great presentation, and we appreciate you coming here and giving us a nice seminar. And thanks everybody in the audience for coming. Like I mentioned, we're going to do Orange County R user group is going to do a webinar tomorrow morning on the R Selenium package, which allows you to test Shiny apps. So hopefully we can see you then. And then we're going to do a webinar in the next few weeks on the rough sets package as well for fuzzy rough set theory and rough set theory. So hope to see you there. Dirk, any parting words, any final words?
No, thanks for sticking in. I hope this was helpful. The questions were excellent and spent the gemüt from beginning to more advanced users. By all means, keep them coming. We'll try to be, as helpful and to the point on the mailing list too, where it's not just me, but a couple of other people too. The mailing list gets indexed too, so that you'll later find it with Google searches. So by all means, go there for questions. That's preferable than just sending it to me because I may be too busy, or you only get 2 eyes on it rather than 4, 8, 6, 12. So the mailing list is a good place, and don't be shy. There's no too early or too easy question, and the most important thing is just buckle down, install the stuff. There's not much to it, and get working from some examples. I think it's powerful, and I hope you'll get to use it to its fullest extent too. Thanks.
Great. Well, thanks, Dirk, and thanks everybody. We're going to shut it down now, and you'll get an automatic email from GoToWebinar within the next 1 or 2 hours with a link to the download. The download should be up on the internet within the next 7 days or so. So give us some time on that, and have a good morning, afternoon, or evening, wherever you are. And we look forward to seeing you next time. Thank you. Take care.